The warning didn't begin with an eruption. It began months earlier when the ground started changing in a way no one could ignore. Across Iceland's Reykjanes Peninsula, satellites detected the land rising by centimeters. Then, within just a few weeks, more than 20,000 earthquakes shook the region. Beneath homes, roads, and the geothermal power plant that supplies hot water and electricity to much of southwest Iceland, molten rock was forcing its way upward. Entire communities would soon be evacuated. The question was no longer if the landscape would change, but where it would break first. When lava finally burst through the surface, it confirmed something geologists had feared for years. This wasn't an isolated volcanic event. It was the return of a geological cycle that had been silent for centuries, and history suggested it could continue for generations. For most countries, that would sound like an unstoppable disaster. After all, no one can stop tectonic plates from pulling apart or prevent magma from rising through Earth's crust. Yet Iceland chose a different response. Instead of retreating, engineers began designing barriers against rivers of molten rock. Scientists monitored the ground around the clock, searching for precious hours of warning before each eruption. Their goal wasn't simply to survive the next volcano, it was to answer a question that could shape Iceland's future. Could modern technology hold its own against one of the most powerful natural forces on Earth? And before we can understand whether that's even possible, we first have to understand why Iceland is fighting a battle that may not end within our lifetimes. If Iceland knows volcanoes will keep returning, why don't people simply move away? The answer lies beneath the island itself. Most volcanoes exist either above a mantle hotspot, like Hawaii, or along the boundaries where tectonic plates meet. Iceland is one of the very few places where both happen at once. The North American and Eurasian plates are slowly drifting apart, while an unusually hot plume of rock rises from deep within the mantle beneath them. Together, they create one of the most volcanically active regions on Earth. But the same forces that threaten to reshape Iceland are also the forces that created it. For millions of years, eruption after eruption built new land from the sea, leaving behind a country that is geologically young and constantly changing. The same geological engine that formed Iceland also produced an extraordinary variety of volcanoes, from quiet lava flows to explosive eruptions capable of disrupting air travel across Europe. And that's where the real problem begins. Most of Iceland's population, major roads, ports, and geothermal power plants are concentrated along the southwest coast, where the climate is milder and the country's economic heart beats. In almost any other nation, that would be the safest place to build. In Iceland, it placed much of the country directly beside one of the most active volcanic systems on Earth. Which means this isn't simply a battle against a single eruption. It's a battle against the very geological forces that created Iceland in the first place. And when the ground beneath Reykjanes began awakening after centuries of silence, scientists realized they might not be witnessing one volcanic crisis at all. They might be watching the beginning of an ancient cycle that history suggested could last for generations. The recent eruptions looked dramatic on their own. But what convinced geologists they were witnessing something much larger wasn't the lava. It was the pattern. When researchers examined ancient lava fields, volcanic ash preserved in lake sediments, and even medieval Icelandic records, an unsettling discovery began to emerge. The Reykjanes Peninsula hadn't erupted at random. Instead, it appeared to switch between long periods of silence and centuries of repeated volcanic activity, as though the entire region followed a geological rhythm hidden across generations. One of those active periods began shortly after Vikings settled Iceland. Their chronicles described fire breaking through the landscape, ash darkening the sky, and years of eruptions that reshaped entire regions. For centuries, those accounts were treated mainly as history. Today, they have become geological evidence. Modern dating techniques revealed that similar eruptive episodes have occurred several times over the past 4,000 years, each lasting not years, but centuries before the peninsula eventually fell silent again. That realization completely changed how scientists interpreted the earthquakes that began in 2019. Instead of seeing isolated eruptions, they began to suspect something far more unsettling. They might be witnessing the beginning of another centuries-long volcanic cycle, one unfolding beneath a modern society filled with highways, geothermal power plants, fiber optic cables, and entire communities that simply didn't exist the last time this happened. If that interpretation was correct, Iceland wasn't facing a crisis with a clear finish line. It was entering a future where eruptions could become part of everyday life. And that forced engineers to confront a question no country had ever truly answered before. If the volcano can't be stopped, can the lava itself be controlled? For most of history, lava has been treated as something people could only escape. Once molten rock reaches the surface, it can weigh more than 2,000 kilograms per cubic meter and remain hot enough to melt steel. Entire neighborhoods have disappeared beneath flows that advanced too slowly to outrun, yet too relentlessly to stop. But in Iceland, people decided to try something that had rarely been attempted before. That became terrifyingly real for the people of Grindavík. As cracks opened beneath the town and lava advanced across the surrounding landscape, thousands of residents were forced to leave their homes, uncertain whether they would ever return. For many, the battle against the volcano was no longer a scientific problem. It was the fight to save an entire community. Iceland responded with something almost unprecedented. Instead of trying to stop the eruption itself, engineers rushed in with bulldozers and excavators to reshape the landscape before the lava arrived. Massive earth barriers, some stretching hundreds of meters, were built in an attempt to redirect rivers of molten rock away from homes, roads, and critical geothermal infrastructure that supplies hot water and electricity to much of southwest Iceland. It was an enormous gamble. Lava doesn't behave like water. It cools, hardens, piles up on itself, and can suddenly carve entirely new paths. A barrier that succeeds one day may be overtopped the next as the eruption changes direction or intensity. Yet in several cases, the defenses achieved something remarkable. Some lava flows were slowed. Others were diverted, and critical infrastructure that millions of people depend on remained protected long enough to keep operating. For the first time, it appeared that humans might not be completely powerless against an advancing lava flow. But every success came with an uncomfortable realization. These defenses were designed for individual eruptions lasting weeks or months. What happens if the eruptions continue for decades or even centuries? Because that possibility forces Iceland to confront a question with no proven answer. Where do you draw the line between adapting to nature and accepting that nature will eventually win? The real lesson from Iceland isn't that humans have learned to stop volcanoes. We haven't. No wall can prevent tectonic plates from pulling apart. No machine can drain a magma chamber or switch off the immense forces operating kilometers beneath Earth's surface. Every successful diversion, every emergency evacuation, and every eruption forecast depends on one reality remaining unchanged, that nature always has the final move. But Iceland has shown that there is another way to think about survival. Instead of trying to conquer volcanoes, the country has learned to coexist with them. Satellites track subtle movements in the ground long before cracks appear. Dense networks of seismometers listen for earthquakes too small for people to feel. Scientists combine those signals with GPS measurements and satellite radar to estimate where magma is moving, giving emergency planners valuable time to close roads, evacuate neighborhoods, and protect critical infrastructure. For the families who live in places like Grindavík, those warnings aren't just scientific achievements. They are the difference between losing possessions and losing lives. Behind every satellite image, Every earthquake measurement and every emergency plan are people waiting to know whether they can return home. It is a race measured not in victory, but in preparation. That lesson may become increasingly important because Iceland is far from the only place living with volcanic risk. Around the world, hundreds of millions of people live near active or potentially active volcanoes. As monitoring technology improves, the methods being refined in Iceland could help shape how other countries respond when the ground beneath them begins to change. Yet Iceland's future remains uncertain. If the Reykjanes Peninsula has truly entered another centuries-long eruptive period, today's defenses may be only the beginning of an experiment that will outlast the people who built them. Future generations may inherit stronger barriers, better warning systems, and more accurate forecasts, but they will still face the same unstoppable geological forces. So, can humans stop Iceland before it's too late? Not completely. But Iceland has shown that humanity doesn't always have to defeat nature to survive it. Sometimes the greatest victory is learning how to live with forces we will never be able to control. And that may be the closest humanity ever comes to winning against a volcano.